So Katie, so we're looking at, did everybody find the page? It's page 13 in your book? Um, we're looking at these shapes, and it's saying, that was a mistake. It's saying below are some park designs. So there's a little bit of reading that goes with this, because why are they talking about this as if it's a park? Where does that come from? Well, like when you look at your book, how come they say park designs? Well, because the page before yesterday's work didn't have to do with parks and, locations on a map. So they're trying to be like tying it into the real world. So it's a little odd. I would say they certainly don't look like most parks, but they could be. But if you're wondering why they said parks, sometimes the book has really good practical examples, and sometimes they have examples that are really good math problems, but maybe not super practical, and they're trying to make it a little more practical. Exactly. Okay, so it's a bit of a reach. That being said, we're going to go with it. And the Euclid City, you think that's like an Emerald City reference?
Whoa.
Euclid's a mathematician, or was. I just was wondering if they were also being reviewed. But, okay, so you have to know, it is true though, in Louisville this is happening, the park, Cottonwood Park has been purchased.
Really?
And then the church next to it, and I'm not sure what's going to happen. So every time that they do a land purchase, if you're going to make a park or something, when you guys before you were born, the community park is brand new to Louisville. It's only about as old as you guys, which is not very old. Pardon me? Yeah. So when they do make parks, it is something that they have to do to consider size and cost, because you have to put grass in, and that costs money, and you have to put sidewalks in, and it costs money. You need to know how much sidewalk space you're going to be pouring, and you have to put trees in, and that costs money, and you have to bring dirt in. Dirt costs a lot of money sometimes because you have to move dirt and it's heavy. Rocks cost a lot of money. Big rocks.
Although before proposing a specific design for a park, I think you would want to know the dimensions. Or the area.
Okay, so that's what we're talking about, right? In order to make a financial proposal of any type, you need to know about the size somehow and the shape. And so they're trying to make this realistic, and then the idea is realistic. The pictures maybe aren't. So we're going to just go with it. Okay. So some park designs submitted to the Euclid City Council to determine costs. The council needs to know the area of each park. Last year I gave you these as little puzzles without any context, and I would just have you find the area. So I was asking if you remember how to do it. Katie said sometimes you could chop them up and piece them together differently. That works nicely on some things. Sometimes you don't have to do anything, right? Like number one, Isabella, what would be the area of number one? Two, right? So if there's nothing fancy to do, don't do anything fancy. Sammy, don't help her. She has to listen. You do. You gotta listen. Okay. So if it's just as easy as writing the area in, write it in, or right below, because yours is darker, right? If it's as easy as maybe just looking at it, and you don't need a formula, even though number two is trapezoid, right? So number two is trapezoid, but you already know that the area of this is 1 square unit, right? So this would be 1.5, right? Because there's that little piece right here, right? And that's half of a square. So don't get fancy if you don't have to. Okay, what about the third one, AJ? I know, I'm asking you. I'm re-engaging you. If you must know. Think about it, because you can do it. That was kind of a pop up. And what would you do? Loved it. Loved it.
You could split the top into two pieces. Like the top, like half, like if you go from like the point next to the three.
Oh, so you're the top being this?
No, like if you look at the three, the dot next to it.
Yeah.
Then you have to go to the dot to the, dot to the dot to the three.
You want to come up and tell me what you're talking about?
Okay. Saying from this dot, you could cut this part in half and then distribute both of these parts evenly. Or just draw a square.
This little piece right here? Okay, that's what I thought you were saying. So, when you look at this triangle, you could see that this piece right here fits in nicely up there. That's what he's trying to say, right, AJ? You guys get that? And in essence, that's what Katie was talking about, rearranging. So sometimes the method of rearranging works, so this is now gone, right? So we knew the top half was how many units? 1. So Grant and Evan, you guys weren't here last year. Does that make sense? As an option? So with that, then this whole shape, which I'm going to redraw now, is 2 units, right? Top is 1 and bottom is 1. So I think I could do that in a different way that might be helpful for people that are not that flexible. Put your pencils down, girls. This is not a race to rush ahead. I don't care. I'm happy for you. But I want you to listen, because what you gain from listening to people is more than one method. And that's what you need when you get stuck. And you hate being stuck. So you really should listen to people's methods, because your method works great until it doesn't. And then if you haven't been listening to other people's methods, you have nothing to bring to the table but your own work. Right? So here's my suggestion. What if you surround it? How much is the square? 4, right? Can you see that this right here is the exact same thing as that?
Yeah.
And this right here is the exact same thing as that?
Yeah.
So the blue area is exactly half of the square. Different. Same answer. AJ could do it his way, I could do it my way. We get the same answer, it's okay. Suki.
I'm a little confused because if you cut the triangle in half, like,
Right?
can I come up with a
Yeah, because I can see another way that's really nice. So if you cut the triangle in half, come on up and do that. I've cut it. What do you want to?
So this side would be 1 and this side would be 2.
She's using a formula. It's true. Base times height is 2.
Yeah.
Divided by 2.
Oh, I forgot to divide by 2 on the side.
That's it, though, right?
Yeah.
So you could use a formula. How about this, you guys? You could take this, right? And just make it one rectangle. I had to flip it, didn't I? No. That's okay, though. There, right? And then you have still 2. So you guys, I was teasing Allie about listening to more than one method, but you're crazy if you think that it's not worth listening to each other, because in just a little bit of time we did this one problem 4 ways, and that's the skill you need when you get stuck. You know, and never put so much faith in one person, that teachers included, that they're going to be able to solve all your problems, right? You want to learn from other people. Allie.
Could you also just divide it in half and then bring down the top part, divide it right there, and the top part comes down and makes 2 squares?
What? Yeah. That's 5 methods, right? So
It can be divided, yeah.
you don't really mean in half,
So yeah, like, but then if you do, yeah.
but then you mean this, right?
Yeah, and each of those pieces.
So you kind of just are taking AJ's method a little farther. Oh, look at it, didn't separate, there we go. So you've got this and this. So that one goes here, and this one goes there, and this is gone. So now we have 2. So how can you guys not like this stuff? I think this is fun.
I do, it's fun. I like it.
Naya's doing nothing but making faces at me. Okay. All right. So watch. So the methods are, keep it easy if it's easy. I would always surround before I chop up. That's me. Because surrounding works when it gets really weird. Chopping doesn't always work. That being said, if chopping is what you see first, there's no problem there. Watch surrounding. So here's this, right? This is what I mean by surrounding. This is 6 units. Do you see the 6?
Yeah.
Okay. Like the purple square, if you think about it as a grid, it was 6 units, right? Okay. I'm going to erase that yellow though, because I want you to think outside. I want you to think about the negative space. Right? The negative space, exactly. This is 1.5 units here, right?
And then you do a half.
And that's a half. So it's just 6 take away 2, which is, that's my method of choice. Surrounding weird shapes. Because I find that, any better? Looking at you still, man. Watch. Surround. The whole thing with, not anything, surround with the rectangle because we know how to do rectangle area. What's the area of that rectangle? 6, right? What's the area of the triangle up here? 1. Because it's half of this, right? You see that? Well, do you see this is 2?
Yes.
And then this triangle is half of it. So it must be 1.
How's that? What?
Ask the question.
How? Wait, why'd you get 1 like
1 is this little white triangle.
triangle?
Okay. 1 is this little triangle.
Oh.
There you go.
Okay.
1. Okay? How about this down here? 1. How about this? A half. How about this? A half. How much was the whole red rectangle? 6. Take away 3. Now, if you guys stopped listening to me, you would all be trying to chop that thing up and make your life hard. I'm hoping I'm trying to make it easy, although there's value in hard thinking. Sometimes the hard thinking is easier. Now,
Couldn't you also just divide it into 3 rectangles?
well, maybe. I'm not
like-
seeing how that would.
If you take a line down where the little dots are and draw 1 line on the first dot, and then 1 line
I
on the
see
next.
triangles. You could also, okay, so we're okay with this though, right?
Yeah.
So we agree the answer is 3. Of course, there's often a second method.
Like,
And sometimes the second method is better for some of you, right?
well, like,
So,
yeah, if you.
so you could do
yeah.
this, which works nicely here. That works nicely. It's just that this inside method doesn't always work. 1, 1, 1/2, 1/2. So it's still 3, right? That doesn't divide into rectangles.
Oh, did I just? Well, because if you take a line, a straight line down from one
You
dot.
can show me on your paper, and we'll look at it.
I think we
Jason, you might be able to. That's why I'm asking you to show me on your paper. Jason. That would be helpful. Okay. Pass it back. You don't have one either? But you're looking at the book pictures, right? So you guys should kind of be doing the work on these. Okay, so here's the thing, guys. I want you to do number 9. Do 9. Huh? So 9's harder again. But did you surround it? Did you try my surrounding method? Surrounding is a beautiful thing sometimes. All right, let's look at 9 together. So I'm hearing 8 from some of you.
7.5.
7.5.
8.5.
All right.
8.5.
So I would say we're not at consensus yet. Would you guys agree?
Yeah.
Okay. So my green square has an area of 16. Okay. Katie, what do you want to do?
Well, first I did the grid, like,
Okay.
I made the grid, and then, I noted that, like, that one right there, like, it's like half, like, no, right?
In here?
Yeah, it's half. Of
Okay.
1 unit.
So I get what you're saying. I would say the grid is a great way to think, but when you draw all over your pictures, you may find that sometimes that's harder than just like visualizing the grid and working in the outside of it. In other words, I'm not going to draw all the marks, but I'm looking for them like you are.
Yeah.
Because I notice when kids do that, sometimes they miss some easy things. So in here, you were looking at these.
Yeah, so I know that they, like, each, like,
All-
we're all half.
So 1.5, right? So 1.5 there. You guys agree with that? So I would avoid drawing a grid everywhere if you don't need to. Like it's easy for me to see that, for example, this is 1, and I can see this is 1.5. Do you guys see that?
Yes.
And if you can't see it very well, a technique is like right on this dot paper. Can you see that it's half of this rectangle? Right, like that rectangle, that triangle cuts it exactly in half. So sometimes thinking off to the side is nice because then you don't have so much writing on your paper that in the end you can't tell what all your numbers meant. So 1.5 there and 1.5 here.
How are you doing the bottom one?
Say that again.
How are you doing?
How am I getting the 1.5? Okay, were you looking down and working ahead?
I'm looking at you.
Okay, watch.
At this and
Watch. Ready? So when I see, let's try a different technique. Same idea, different. Look at the diagonal line, Allie. See the diagonal line? Let me pick up another color. Right here. That diagonal line is always a diagonal of some rectangle. So this is the vertice of the rectangle, and that's the vertice of the rectangle. So the rectangle is right here. Do you see that? Like this diagonal line that I was drawing right here, cut some rectangle in half, okay? So what I'm saying is, try to visualize the rectangle. Here it is. It's that size rectangle. How many units is that rectangle? 3. And this triangle right here is exactly half of that rectangle. So it's half of 3. You see that, you guys?
yeah.
Keep trying to look at it. Okay, so, and we can work a little bit one-on-one. So that's the same as this one up here, right? Yes, no, okay. So then down here, can you see like this is 1 and that's a half? And that's a half right here, right? Okay. Are we good there? So then we started with 16, didn't we? And then we're going to subtract out, well, 1.5 and 1.5 and 1 make what? 4. And then this is another 1.5 and 1.5, so that's 3.5, right? So minus 3.5. So altogether, it's
9.
8.5.
Nail.
The shaded area, how many people, there was some 8.5, who had 8.5? Okay, not the whole class, because I heard all these other numbers. Okay. Okay, time out, guys. Sammy. Oh, you had it, okay. So your homework. Due Wednesday, because the other part of your homework, Katie,
Do it tomorrow.
that's not what we're doing right now. Well, tomorrow you're not gonna be here very much, right?
But didn't you just said do Wednesday.
I mean, due Thursday is both sides of this worksheet, okay? But tonight, you're gonna first go home and do what I said, you're gonna listen to the video of the ACE questions from last night, because we didn't take time to do that today. And I'll post this too. On, I'm still